Hello everybody, my name is Kimal Anajam and I will be the instructor for this course or the course facilitator. This is an introductory calculus-based mechanics course and it is a foundational course required for students in physical sciences, engineering, as well as in medical sciences. Now, there are two major objectives that we will strive to attain in this course. The very first objective is to help you to understand or comprehend the core concepts and principles of Newtonian mechanics. By understanding or comprehension, I mean that you should be able to think with the principles and the concepts that you will learn in this course. Now, the second objective, which is a derivative of the first, is to help you to develop the critical thinking and the creative thinking skills required to analyze and solve complex and challenging problems in Newtonian mechanics. You cannot do the second unless you attain the first. So the two objectives are very important. They are more like two sides of the same coin. So everything in this course will be organized to ensure that you achieve the above two objectives. So keep that in mind. This is an introductory calculus-based mechanics course. So the question really is, what is mechanics? Mechanics is the study of motion. That is the simplest definition I can give. Now, it can be more than that, but I'll prefer to leave it that way for now. Mechanics, for the sake of this course, we will divide this course into three parts. You have kinematics, which is basically the mathematical description of motion without taking into account the causes of motion. You will have dynamics, which will take into consideration the forces that brings about motion, and we have statics, which is simply the study of systems in equilibrium. So we will break down this course into three parts. Kinematics, which is the mathematical description of motion. Dynamics, which is the study of motion taking into consideration the causes of motion. And you have statics, which really is the study of systems in equilibrium. Now, if we really are to analyze systems or objects the way they are in nature, the mathematics required is way beyond the scope of this course. For example, if we throw, let's say, a ball in the air, to be able to analyze the motion of the ball thrown up in air, we will require to take into consideration the buoyant force, the drag force, air resistance, and so on and so forth. We will actually have to take into consideration the gravitational pull of the earth. And this really might complicate the problem and take it beyond the scope of this course. To keep things simple, we will break down the body of knowledge that you need to know into models. A model is a simplified version of a system or the behavior of a system. So we will look at these simple models and then project using our models to be able to describe how a system will behave under a given set of circumstances. Now, the very first model that we will talk about is what we call the particle model. In this model, we will consider the mass of objects such as you or a car or a book or this computer in my front to be concentrated at a single point. We call that point the center of mass. Now, if the mass of an object is concentrated at a single point, it means that by studying the motion of that point, we can actually study the motion of the whole system. We call that system a particle system. Let me put it this way. A particle is an object or a system whose dimensions and size is irrelevant for the description of the motion of that particular object. So when we reduce a system or an object to a single point, we call that point a particle system. A system is a fancy word in physics used to describe an object that we are interested in. For example, if we are interested in the motion of a car, then that car is our system. If we are interested in the motion of a car with passengers, then that car with passengers is our system. So when we use the word system, all we are talking about is an object or group of objects that we are interested in. This definition is remarkably different from what you will hear in biology or in chemistry. So keep that in mind. So before we go, understand that this course is broken down into three parts: kinematics, which is the description of motion without taking into consideration the causes of motion. You have dynamics, which is the description of motion taking into consideration the forces that brings about motion. And you have statics, in which we will study systems in equilibrium. Thank you so much. I look forward to the next lesson. Bye.